Good afternoon, one and all. I take privilege in introducing this session's resource person, Dr. Myna A.N. He is professor and head of Department of Computer Science and Engineering. She is the former vice principal of our institution. Dr. Myna completed her BE in Computer Science and Engineering from SJC Mysuru in 1995. She completed her post-graduation and PhD from Vishveshwaraya Technological University. She has a teaching experience of more than 28 years. She has served in Malnad College of Engineering, Hassan, MS Ramaya Institute of Technology, Bengaluru, and Naukis College of Engineering, Hassan. Her broad area of research is image processing. She has worked on image registration during her post-graduation and on image vision during her doctoral work. She has published more than 30 research papers in reputed international journals and conferences with more than 160 citations. She has presented a research paper in the World Congress held at Los Angeles, USA, for which she received travel grant from Department of Science and Technology, Government of India. Dr. Myna has worked as member of Academic Council, Department Advisory Board, Board of Studies, Board of Examiners in autonomous institutions and universities. She is a member of professional bodies like IEEE, ISTE, and IIENG. She is fellow of IETE. She has received IEEE Mysore subsection Overstanding Volunteer Award in recognition of outstanding contribution to IEEE Mysore subsection in the year 2021. She has organized various workshops and faculty development programs. She has worked as a member of the organizing committee for various international conferences and has received research papers for conferences and journals, reviewed research papers for conferences and journals. She has also participated in various faculty development programs and conferences. I am very happy to introduce such a great personality to this session. I welcome you, ma'am.
Thank you so much for the introduction, sir.
Thank you.
So,
Please take this.
so the topic of today's session is how you can use fuzzy logic to develop artificial intelligence applications. So as I've already told you, if like we will download the MATLAB version, trial version first. Gmail account ಕೊಡ್ಲಾ? No, did you create the account in MacBook? You could create the create account. Okay, it's okay. So later, like once you go home, maybe the problem with the I connected the same Wi-Fi and I downloaded on my system just last week. I did that. What password? I got that. Okay. See, these are the different branches or domains of AI. AI, as discussed yesterday, is not just machine learning. It's not just deep learning. Basically, AI, the branches of AI are these: machine learning, deep learning, robotics, expert systems, fuzzy logic, and natural language processing. Okay, these are the five domains of artificial intelligence. Whereas the machine learning, when we say machine learning, as we already know, to train using machine learning algorithms, we need lot of data, right? And even in deep learning is the next level of artificial neural networks. Artificial neural networks is a part of machine learning. Other than artificial neural networks, machine learning has many more technologies. So one of them is neural networks. And in neural networks, when you have more number of layers, it becomes deep learning or deep neural networks. And when we talk about expert systems, it's all based on decision making. So most commonly, expert systems are based or you are designed for making decisions where if then else conditions are used. But when we talk about fuzzy logic is used to handle uncertainty, or when we have systems where vaguely the logic is, or say vaguely the variables are defined. The variables have a vague definition when the values are not just 0 or 1. Okay, when the values lie in between 0 and 1, we go for fuzzy logic. Again, fuzzy logic is used to take decisions, and most commonly, fuzzy logic systems are used in controllers. For control systems, fuzzy logic systems will be, fuzzy logic technology is used. For example, washing machines. Okay, the AC temperature controlling. When we say, and we'll take some examples like that. So I just want to give a brief introduction about fuzzy logic. Today it is not in 1 hour. Maybe I'll take for 1 hour. It is not sufficient. I'll just take an example. I'll show you how fuzzy logic works, and then we will go into the details of how fuzzy logic works. Today's class we will just see what fuzzy logic, or how we do we program using fuzzy logic, what type of inputs and outputs we give. Then we will go into the details. Only then will you be able to understand. Otherwise, the concepts of fuzzy logic, it's like completely mathematics, and too much of calculations will be involved. We'll go into the calculations if time permits during this FDP. Whenever possible, maybe I'll engage 1 hour or half an hour session where we can discuss about the calculations of how decisions are taken. For example, now in washing machines, when we say the clothes are dirty, okay, are the clothes dirty or not, or how much, say the water that is to be released by the washing machine, or what is the amount of detergent powder it should take. Okay, if it has to be done automatically, then it has to check what is the level of dirt, or what level of dirty the clothes are. When we say clothes are dirty, like there is we cannot tell it say either dirty or not, or how much is it dirty. When we say, we cannot give a value between 0 and value 0 or 1. It will be a value in between 0 and 1. Okay, so probabilities are involved here, where we say when we define a variable. Now the linguistic variable is dirty. Okay, the linguistic variable is dirty. What amount of dirt is the probability value, isn't it? When we say you're a tall person, suppose I say short person. For me, any height between 5 feet may be tall. For you, maybe 5 feet might be considered as, let's say, for me 5 feet, below 5 feet can be considered as short. Maybe for you 5 feet is tall. Okay, maybe for some other person 5 feet might be a medium height. So when I talk about tall, I mean the height of the person. When I talk about the height of the person, we can call a person as short, tall, or very tall. But what is the value that I assign? When I take values in centimeters, say some maybe 160 centimeters or something, 160 centimeters or say 150 centimeters. Okay, from 0 to 150 centimeters. Again, for me it might be short. For some other person it may be medium height. For some other person it might be tall also. Again, if you go to China or Japan, okay, if you are 5 feet, maybe you are the tallest person. Is it not? For us, 5 feet, maybe we consider as medium height. Maybe you go to countries like Afghanistan, where people are very tall, then 5 feet is a short person for them. Okay, so the range, that means what I'm trying to tell here is, when I ask you if a person is short or not, I cannot give the answer in yes or no. There is a value in between that is called as the fuzzy value. Okay, for most of the variables, when the value is fuzzy, when the value doesn't lie in between 0 and 1. Is the weather hot today? Is the weather hot today? Again, I cannot give the answer in 0 or 1. Maybe I'll feel that this is the weather is hot. Okay, some other person might tell it is cold. One more person can tell it is average. Is it not? So, maybe depending on the weather condition, I'll have to add that depending on the temperature, the AC controller, if it is an automatic AC controller, the controller has to adjust the AC. The fan speed has to be adjusted based on today's temperature. Again, today's temperature for every person. So that means this value temperature, the value of temperature or telling the weather is hot, cold or average or medium, it has a vague value. Okay, the value we cannot give it in 0 or 1. It will be a value somewhere in between. So those are called as fuzzy variables. These variables are called as fuzzy variables where we cannot define a value either 0 or 1. So if the weather is hot, I can say set the AC fan speed, so much of degrees. If the weather is cold, set the AC temperature again either for high or low, whatever. Okay, so the main reason that when we use fuzzy logic is we have got something called as fuzzy variables which will not give you the exact value. The values are vague or there is uncertainty there. Got it? When there is uncertainty, we use this term fuzzy. And when we design fuzzy systems, I'll just take one system. Just go to MATLAB. We will take a problem where we take the problem of traffic controller. Today's class I'll just show you how fuzzy logic works. Traffic controller. Okay, so we have north-south direction. This is north direction, south direction. We have east-west direction. Okay, I have a traffic controller here. Okay, suppose the traffic controller is there. The job of the traffic controller that we are going to define should be to set the traffic signal, green signal, okay, for the north-south direction. So the green signal, the value of the green signal will lie in between 0 to 60 seconds. 0 to 60 seconds. And the conditions are that it has to see the traffic on the in the north-south direction and also the traffic in the east-west direction. So the traffic can be the input variables, say the input variables. So because I am setting the north-south directions traffic signal, I take the traffic in the north-south direction and also the east-west direction. So I will have say two input variables. One is north-south density. I call it as north-south density. Another one I call it as east-west density. These are the two input variables. North-south density, traffic density, east-west traffic density. The value that I can give for the north-south density, I take it as low, medium, high. These are the values. These are called as this is fuzzy. When I say low, I cannot give a value, I can give a range. Is it not? I can give a range, I cannot give a specific value. When I say medium also, the same thing. When I say high also, the same thing. So this these are fuzzy variables. These are called as fuzzy variables. This also can be low, medium, high. These are the three. We call this as three values which are fuzzy in nature. In the output could be anything between 0 to 60 seconds. Any value between 0 to 60 seconds. I call the output variable as EW, the north-south signal. Okay, north-south signal, which can be short, medium, or long. Short, medium, or long. Okay, these are the three values that the output will take. They're all linguistic. They're called as linguistic variables, for which I have to define the range. Now, suppose the problem is this, where the north-south. Did you understand the problem? I am defining a traffic controller to set the traffic signal, to set the green light on. We have to decide for how much time should the green signal be on. It should be a value between 0 to 60 seconds. Okay, and then the traffic, maybe the input to the traffic for the traffic controller that we are designing, we will directly give the north-south traffic and the east-west traffic. Otherwise, you can have a camera installed and the camera can give the input to this traffic controller whether the say north-south traffic is low, medium, or high. The length, it can just take the number of vehicles that are there till where the vehicles are there. So that length, if those values are between 0 to 100, okay, the north-south density, the value can be between 0 to 100. This also can be 0 to 100. Now we have just two input variables and one output variable. One input variable is the north-south density, north-south traffic density. Another input variable is east-west traffic density. The output is our controller now has to decide for how much time the green signal should be on. Generally, how do you write these programs? Forget about fuzzy logic. If this is the problem given to us, in general, how do we write? In any language, in any programming language. When we use binary logic. when we use binary logic, how do we write this program? The problem is this. Looking at the traffic density on north-south direction and east-west direction, the signal timing has to be found out.
Control statement.
Yeah, tell me the control statements.
If arm is, then it is operation.
Tell me that. If okay,
If east to west
if NS density, what?
is equal to medium.
Is equal to, no, forget fuzzy. If you are writing in C, normal C, if north-south density, the value can be in between 0 to 100. What do I do?
60.
Greater than?
60.
Greater than 60?
East west green.
And east-west density less than 20, okay? Then
east
this is the output. NS signal
green.
equal to D.
Green.
So it is green only. No, we are deciding the timing for green. No, like I want a value in between 0 to 60.
60.
So 60, okay. Then if what else? What other conditions you write?
If density is less, you have to reduce.
Density of this is
Less.
less than 60. Less than 60, okay. And PW density greater than
20.
greater than
20.
EW density you are talking of.
You have to reduce the timing rush.
Yeah. Suppose this is greater than 60. Isn't it? Then NS signal is equal to maybe it's somewhere in between. So more traffic is here. More traffic is here. Less. Yeah. Suppose we will set this to 30. Isn't it? That is how we write in our normal program. So, like this, we write many conditions. Isn't it? Like this, we write many conditions. So when we write conditions like this, one after the other, so one is statement. One is statement will give me value true or false. Is it not? The first if statement gives me a value either true or false. I'll next come to the next if. Next if again, that will also give me either 0 or 1. Okay, so I cannot write innumerable number of conditions here. And when I tell greater than 60, for example here, the range, suppose this is the traffic range, this is for NS density, okay, NS density greater than 60, say something 70, something like this. Okay, if I have a value here, some 70, this is suppose 70. Okay, this is 70. So for 70, for this condition it will work. Okay, for when I say greater than 60, less than 20, it will take this range. Okay, and then the conditions will be executed one after the other. But again, this is like just two input variables we have, one output variable we have. So writing this, like somehow we can write this, but again we'll have to write many conditions just for two variables because the range is there. You'll have to write many conditions. And sometimes what happens, there could be some overlapping also. The conditions could be overlapping also. So in such cases, what we do, the same problem, if we solve using fuzzy logic, we will see how it is done. The problem is the same, but we will see how to solve it in fuzzy logic. Fuzzy logic, as I told you, now instead of